Okay, so we're going to do another video today on our AP study guide for stats. We've done categorical data. This one is going to be for quantitative data. Make sure that you stop the video as we're going so that you can keep up and write the notes. Okay. All right, so find your quantitative data of one variable. Go ahead and open up, and we're going to go to the top. Okay, so we're going to start off similar to what we did with the other one. Quantitative data, remember this is when you have measurements. Okay, and let's first off talk about the types of graphs. And you'll notice the spacing and the size that I write on. I have it spaced out so it fits perfectly, so you want to kind of do similar to what I do. If you want to write smaller, you can, but I would not write any bigger. Okay, so when we have our different types of graphs, the main one we're going to have is a histogram. We've done a lot of histograms. You may have to draw histograms on your AP exam. If you do, the things that you need to look for is bars and bins are connected. So things are connected. Your axis is consistent. So if you go up by 5, then you go up by 5 the whole way on the x-axis. Same thing on the y-axis. If you go up by 10 on the y-axis, you continue that trend on the y-axis. Your y-axis has two options. It can be counts or percents. It's up to you what you want your histogram to be. Okay. We can easily graph histograms in the calculator, but sometimes I find it easier just to graph it by hand than having to translate what the calculator said. So if you're having to do a problem that says to draw a histogram, my suggestion is just figure out bins, count how many are in each one, and graph it. I think that's much easier than putting it in the calculator. The next one we have is stem and leaf. And remember, you can only have one number in the leaf. And then you have to make a key. Don't forget the key. And so if I have 53-1, I can only have, this is the leaf right here. I cannot do 531 if my answer is 531. This is correct. This is a no, because it had two numbers that represent the 31. Remember, the numbers in the leaf don't have to go in order, but the numbers over here in the stem do have to go in order. And remember, you can't skip stems. So don't skip numbers in the stem. Okay. The next one we had is a dot plot. A dot plot is a real quick way just to show evidence of what something is. So if I only have 5 or 10 numbers, I would not make a histogram. I'd probably make a dot plot. Okay, then there's next thing is the box plot. Box plot is one I would probably do in the calculator and then just figure out an axis and use that because it does all the math for you. Remember, for a box plot, it has a box. This middle line is the median. This left side of the box is quarter 1. The right side of the box is quarter 3. Remember, we have something called fences. And you don't actually have to show the fence, but you have to write it down or recognize where it's at. And you take your point all the way out to where either the min is or the max is. But if my max or if something else is outside here, if it's outside of the fence, then you draw this whisker until the next point, until the smallest, the data piece that's right before the max. Remember, a box plot, the bad thing about a box plot is it does not show humps. So if you're looking to see if it's unimodal, bimodal, multimodal, you have to look at the histogram. And then, so we need to write some stuff. Outliers. I wrote a little too big on this one. Outliers are outside of fences. That's how you can officially tell if something's an outlier, if it's outside of the fence. And then remember to find the fences. You do quarter 1 minus 1.5 times the IQR, and you do quarter 3 plus 1.5 times the IQR. And remember, IQR is quarter 3 minus quarter 1, which we'll write in a second. Okay, so there are some other things we have to try and figure out, and we're going to try and squeeze it all up here. Let's squeeze in the 5-number summary, because you need that 5-number summary to be able to graph a box plot. So if you graph a box plot, somewhere you need to list these numbers just as evidence. And remember, the 5-number summary includes the min, quarter 1, the median, quarter 3, and the max. And then here, remember, you find the IQR by doing quarter 3 minus quarter 1. And IQR is a measure of spread, about how far things are away from each other. And then the other thing with histograms and quantitative data, we need to look at shifting and scaling. So remember, shifting is when you add or subtract something to all the numbers. So if I increase the price of something by $5, so everybody's ticket price went up $5, that would be shifting. For shifting, plus or minus to measures of center. So if my ticket prices all went up $5, then that means my mean would go up $5. That means my median would go up $5. It means my max would go up $5. So it's anything that talks about a location would go up or decrease by that amount. This does not change the spread. Okay, and then there's scaling, and again, we're getting tight in here, but we can make it work. Scaling is when you times everything by a number. Everything times this. So you do that by everything. So when you multiply, let's say I double my ticket prices, every measurement will double. The mean will double, median will double, standard deviation will double, everything will double. Okay, so we got histogram, stem and leaf, dot plot, box plot. We do have one other type of box plot, and again, this is probably the one that I would see on an on a FRQ question. The next one is parallel box plots. The main thing you have to do with parallel box plots is you have to have the same axis. So if I have one axis here, I would have one box plot, and then I'd have another box plot. So they're on the same thing. They just hover above each other. Make sure you label, maybe this is boys and this is girls. You do have to label which is which. Okay? All right, one other thing before we get to a big part of what quantitative data is, the next one we need to talk about is the nearly normal condition. It was a little confusing when we first were learning this, but we've done nearly normal so much now that you might remember and understand this better. And that's if things are unimodal and symmetric. You use 68, 95, 99.7. And that's also called the empirical rule. I don't think they'll call it that, but if you see it, I don't want you to be freaked out of what that is. That's just saying that 68% is in the middle, then the 95% is 2 tick marks away, and 99.7% is 3 away. All right, the last thing that we have is describing normal models and or quantitative data and histograms and box plots, and this is a big thing. And remember, when we describe these, we use our SOCs. So remember, S stood for shape. When we describe the shape, the things you talk about is it being unimodal. It could be bimodal. which is 2 humps, multimodal, which is more than 2 humps, or uniform, which is no humps. Remember, to signify a hump, there needs to be several bends between them. If you go down just for one bend and then come back up, I would not consider that multiple humps. Okay, you also need to talk about whether it's symmetric, skewed, and then where the tail goes. Remember, I would never say anything symmetric. I would say approximately symmetric or roughly symmetric. Okay, the next one for O is outliers. And this is where you list any possible outliers. And or gaps. You need to try and state them specifically. If you're able to see them, you want to state them specifically. Okay, C stands for center. And for center, if it's symmetric, oops, there's only one R in symmetric. If it's symmetric, you're going to use mean. If skewed, you use median. And then the last one, S, the other S is for spread. If symmetric, you use the standard deviation. If skewed, you use the IQR. Okay? Remember, when we're describing or drawing these things, you need to write your capital N with what the mean is you use and what the standard deviation is. So this means they're using a normal model, or you're using a normal model with mean of 5 and standard deviation of 1. So whenever you draw a normal model as part of your evidence, you need to write this. Okay? The last thing when describing, remember, you must describe in context. You've gotten better at it, but it's still something that sometimes we forget. Okay, so that's it for quantitative data. If you have questions or are not sure what I meant by any of those, make sure you come and ask.